Hi, my name is Keenan Hardert. I'm a biology professor at Mankato State University, or Minnesota State Mankato University, and I do cancer research and biology education research. And today in Prism, we're going to learn how to do multiple linear variable regression. So this is a very good tool to be able to see if there is a dependent variable, essentially, like something you want to see, like how it's going to predict. What do the little independent variables, like how much power in prediction do they each have? And are they each significant? And the relationships they're in. So analyzing these relationships for the outcome variable, we're going to do some data setup, model interpretation, check the assumptions, and Prism has all these tools for you. And we're going to help identify the relationships, not only between the little independent factors that predict the outcome, but the relationship between them. And if the test is valid, and if there's co-founders, for example. So this is one of our more robust statistical models because this can actually identify, is your model trustable, essentially? So I'm going to load everything in. We're going to run a quick analysis. I do have some other data, as you can see in four. That's just a quick XY plot in the old version that we can graph. All right, so I've loaded in some data. Here are the students' final class percent. Look at, yep, final one up there. Their collective lab percent, how they did in the lab, part of the course, quiz, and the three exams, the third one being the final exam, and how everybody did, essentially. All set up in rows, looking pretty good. This is in the multiple variables setup in Prism. So after I load this in, I would actually begin the new analysis right here. I'd say, yep, multiple variable analyses, multiple linear regressions. So let's take a look at this. You could do two-way interactions where you would measure combinations of each independent variable, but in this case, let's just state a main effect. This can definitely help in some cases, but we'll just keep it normal here. So the dependent variable that we want to predict, how's it all going to shake out? So let's say if I have my fifth class and I would tell them I can use these stats to say, here's the influence that each one of these assessments is going to have on your final outcome. The lab, the quiz, and all three exams, including the third one, the final. So class is what we want to see. How is it getting predicted? It's the final level. It makes sense. Most of the default settings in here are all set. References would be in here if you did include a categorical variable. So if I had put in my thing where it says attendance high or low, you technically can still do a linear regression on that. Prism will automatically put in sort of a dummy value for that and say like what's the 0 or 1 value here for us, and it can go here. That said, I'm going to stick to some good normal quantitative data right here just to be safe. Interpolations, compares, and again, what we're kind of looking for in each case. You can customize this a bit, but for our cases, we're just going to keep things good. Now, residuals, I'm going to keep all these plots because the residual is for each individual student and row, essentially, what is the difference between the actual observed value of that dependent variable and the value predicted by the model for a given data point? So if it worked well, we should see kind of a tighter distribution of the residuals, and they should follow more of a normal distribution themselves. Now, the strange thing is, and the cool thing that I love, is that these plots are still going to show us where rows really like went off the handle and did not get predicted like their peers. So it's kind of neat to see. All right, let's run it and let's kind of talk about these. So right away, here we are. There's sum of squares right here for each of our setups. Let's go look at all these little variables right here. So sum of squares is like kind of the raw influence space on the dependent variable. And that is kind of our like initial building block to say how strong of each of these is a predictor, right? So going over here, I'm actually gonna take us over here right here. As we go over to the beta values, though, this is where the test essentially starts giving us pretty good stat values. Here's where here, and I should highlight right here as well. The beta values are essentially going to tell us what estimate and change in the dependent variable for a 1 unit increase in that independent variable in each case, while holding all others constant, is going to happen. This is essentially saying like per unit of change in this independent variable, what are we going to expect in the dependent? So it's very good. Again, we have our own spread on here of 95% confidence in the beta value itself. We have, again, sort of a t-test that sort of, again, shows kind of power of separation for the group. But wonderfully, we have great p-value summaries right here. And even right away, we have something that you could graph if you really wanted to show it and say, lab turns out is the highest beta value and is the most powerful factor in predicting how you end up in the class. I love telling my students this because a lot of them are like, oh, boo, lab. I'm going to focus on the exam. Right here, I have the stats to say how you do in lab is a greater influence on how you do in the class as a whole than any of these. Now, that said, if I did say like the average exam score and got rid of these, maybe that would be a little higher. But a lot of good setups right here. Um, how the goodness of fit right here. This is more of an R squared as a whole for the intercept itself with the predictor. So really solid right here as well. We get something VIF right here, which is a very good way to say variance inflation factor. It's a measure of the amount of multicollinearity in the regression analysis. You actually don't want to have this number go very high. Anything above 5 means that it's kind of being influenced by the other factors and not serving very independently. So if you had anything up here that was way too high, you would start to question like, is this the right model for this? Is this prediction value that I'm getting up here really something I want to bet my house on? So down here, we're going to do another set of tests here. The residuals, like I said, are the amount that the actual points deviated from the prediction. In this case, are those residuals in a normal distribution? And looks like we're good right here. Excellent. If they were not, if these were significant, it would say, your residuals are not really behaving normal, because you would want like theoretically extreme ones that like did break the system on either side, but most would sit in the middle of the system, kind of like a nice histogram of normal distribution, right? It's testing this on 4 different ways. So as long as you are okay in terms of that, they're normal. This test right here did almost get us a little bit, let's say. So what the VIF is kind of also looking at is rawly put in right here with parameter covariance values. So in this case, the little title slide over here is going to give you the covariance kind of correlation R value type of thing between each variable. So the intercept value itself, how are those kind of being predicted in this case, things like that. But even here, if I wanted to say, -3, so beta 2 and beta 4, quiz 1 and exam 2 really did not they actually kind of influence each other in an inverse way in this case, but that number is not high enough to the point that like we would say like, oh, the value is untrustable. This is similar to the Cox regression analysis that we did with categorical variables in survival, in that sense, kind of predicting things. So let's take a look at these plots. So here's the actual class percent, and based on the model, how everybody would have been predicted. So you can tell this is a really good fit. This is that R squared of 0.94 that we saw before. We do see some right here. So like row 51 deviated. They were predicted to have a much higher class percent, but they didn't as much. So they were predicted to have about a 70 class percent, but they only got about a 60 in this case. So that's kind of neat. All right, here we go again. Predicted Y and the residual itself. So basically, how far off were you for each row? So this is all 251 of my rows that I input for all the students. So I can find ones that there's row 51 right there. Like I said, it is -10 away from the predicted value. You got a lot of overperformers up here. Row 210 overperformed the prediction by 5% of class points. So pretty neat. As you can tell, most of them kind of stay in that zone. Again, and Prism is going to give you the option to kind of look and use graphs to show in each case the absolute residuals, how much you're looking here, things like that, versus the prediction. And that's their main goal, is to show, hey, how good was the model? Were the residuals out of control? Because if they were spread out everywhere on this graph, the model wouldn't really be that predictive of our Y, our class outcome. And we would maybe say, well, maybe other things are predicting that. So again, predicted residual versus actual residual. So you're kind of examining the examinations in this case. Again, looks pretty good. Residual versus order. This is just row number. This is just saying how I listed the data. So this is not the y-axis, or the x-axis here is just the order that I input things. I did input the order as like top class performers versus the lowest to the right. So this actually does still give me something. If you input the data in a linear format that is organized, you can actually use this graph to say, hey, to be honest, even if everybody over here is my top performers in total class, the model kind of stays pretty consistent in this case, between about 5% in class is the like kind of window that you're probably going to fall in no matter what, even if you do poorly or do super well. And then here's that parameter covariance table that we saw, just put as a heat map. Again, you'll have to input your beta values for each one. But as you can tell, not too much collinearity, covariance, because what this really helps you with is making sure, and I'm going to take us back to the results, that you do not have this VIF value. None of the factors are confounding each other. Not one is taking over and so pushing the other that you can't treat it independently. And that's the beauty of this analysis is that we've got all these data. And essentially what these data are going to really help you with is when you perform analysis, you can say, you can trust my predictive model because none of my independent variables are individually influencing the other ones. They're all acting on their own and thus, or at least statistically on their own. And thus you can trust the raw influence that I'm showing and the raw p-value that I'm showing you. So given everything, I did also in terms of just graphing things straight up and adding like a nice little line, if that's what your game is, I would go back to the format of just regular old XY out of multivariable. I would say, hey, let's go take a look at some fun graphs right here. Again, there's my class percent. Here's the various assessments now listed in colors over here. If I wanted in this case to say, hey, fit me with a simple linear regression just for a graph, this is still the good XY is still one of my favorites. I'm going to show the 95 confidence bands, for example, for each factor. I like that. I could make a residual plot again, but I already have that. So I should be fine here. And again, this is mainly going to be if I want to say, hey, I want to see this put into interpretation and kind of go from there. And each one of these you can kind of customize. So here, watch this. For each regression, you can sort of customize and say like, hey, I want my own specific error bars and dots for everything. So see how I changed the dots on the confidence interval right there to reflect the same bluish color that I was giving that assessment already. So again, I do like you can still use multivariable graphing. That's perfectly fine with what you got. You can even graph the residuals and make them look really good. If you are simply looking more for an XY with multiple regressions like this is also a nice way to still do things. Prism still offers that great avenue. So I would say, thanks for watching. And I think this was a good learning experience.